We ready to begin? So while we start, last time I forgot to just check names again and how we're doing. So why don't we go around again? Just remind me of the name you like to be called. There. So why don't we start? Layla. Okay. What was that? Okay.
Sophia.
Yeah.
Joe.
Oh, okay.
Miles.
Okay. Okay.
That's right.
That's right. Yep.
Nicholas.
Okay. Nicholas. Okay.
Alec.
Yeah, Alex over there.
Who's it?
Okay. And
Fabian.
Fabian, yeah, let's see, you are now. I just have a little scene shot. I'm moving people where they are on some of this. Okay. What? Okay. And all right. And Osmos?
Elias.
Elias. Okay. Sounds good. All right, thank you. Hope you had a good weekend. I love this time of year. I love September. Is probably my favorite month, although sometimes it gets really rainy in Minnesota September, but this is perfect, I think, where it's just the 60-degree weather and sunny and stuff. And there's not so many bugs. I spent Saturday at our cabin in the woods, and there can be lots of bugs sometimes of the year, but this time of year, really nice there. So some of you were at the welcome party on Thursday, so thanks. I think I had a good time. We had some sandwiches and stuff. I don't know if some of you didn't stay around till the highlight of the party was when we were leaving, we decided to play, so we try to get our focus in, right? And we played bean bags, and that was a blast there. And again, great weather for that. So thanks everyone who was there at my house. So it was a fun time. Another reminder is DigiKey will be here tomorrow. So tomorrow for lunch, they'll be, I think they always have pizza. And usually we get good pizza, like Pizza Luce pizza here, which in Duluth is good pizza. So that's my expectation. So that'll be tomorrow at lunch. So again, you're welcome to join, come there and learn a little bit more about DigiKey and their jobs, even though again, they're looking for juniors, but they're willing to give everyone pizza in the hope that in the future, when you are a third-year student, you'll want to work for them. Here. So, okay, what are we going to do today? So again, second week, second unit. It's pretty straightforward in this class for this. Remember, if you, from unit 1, if you didn't post something to the discussion area and reply to someone's discussion area, you should do that. And then the assignment, code to display a song, you should have submitted that. It's not officially due till tonight. So again, if you have some questions on that, later on, we'll try to end class just a couple minutes early so you can ask, if stay around and ask if you have trouble uploading it or doing something like that or getting it, because again, it takes a little bit often to zip it up in a file and submit it there. So we can we'll have a little time at the end of class if you have questions on that. So again, that's from unit 1, but we're going on to unit 2 today. And I'm gonna hide this old Zoom link and I'll be posting a new Zoom link there. So today we're just gonna go over the learning materials, particularly the first part on variables and talk about variables. Wednesday, we'll start talking about input and how to do input. And then we'll do this, I think we'll do the Mad Lib on Wednesday, I think. We'll see. And we'll walk through some of the practice problems on probably Friday, I think. I think that's what we'll do this week. So, so let's just go onto the learning material and look at that. So we're going to look at variables and then how to combine variables together, do different operations on them. So I posted some pictures of storage because basically that's what variables are, is how we store things in the computer. So a couple things to note here is that in a lot of times storage, okay, maybe not everyone's storage, but some people's storage, if it's organized, we labeled. Everything is labeled. We have a name on every bin, what's in that bin. And in computing, we have to stay organized. So every variable's got to have a name there. Now also notice that the bins are different, the storage is different sizes here. So if we're storing a big thing in it, we'll have a big bin. If we're storing a small thing in, we'll have a small bin. So we'll have different size storage here. So when we store something, we also have to say kind of like the size, or what we'll call the type. What are we going to be storing in this bin, in this variable here? So we have to specify a name and then the type, or what we're storing in that bin, because different bins, different variables are different sizes. And again, we can sometimes move something from one size bin to another size bin and convert it there, but sometimes we have to do things during that conversion. So like if we have, long spaghetti noodles in one bin over here, and we want to move them into a smaller, shorter bin, well, we might have to break the spaghetti noodles and throw some of them away and just keep the shorter versions of the spaghetti noodle. We might have to do some sort of conversion. We might lose something in that conversion as we go, but there might be some conversion as we switch from one data type to another data type here, as we'll see. So let's actually get into this a little bit. So again, these are our three kind of sources, and we'll be kind of jumping back and forth. I'm still going to be looking at all three a lot, so that you kind of get an idea of which of these three you like. And I actually think it's sometimes useful to see how the different sources or textbooks kind of cover this. So I'm going to start with CS Awesome here. And section 1.3 talks about variables and data types. Here again, you can watch this video or stuff and talk about this data type here. But basically, there are 4 data types. It's going to talk about int, int, which represents an integer, double, which represents a decimal number. So double represents a decimal number here. It's another type is float, a floating point number, which is another word for decimal number. Now, I'll just tell you there are more data types out there than we're going to talk about, but we're going to focus on the most important ones. So like for decimals, there is a data type called float, but no one really uses it anymore because it's just not precise enough. So there's what we call a double precision float, and that's what we use, and that's why it's called a double there. It's a double precision float. And everyone so again, it's just kind of weird that it's called a double there, but that's a decimal number there. There's a Boolean. So both of these store numbers, different types of numbers, but numbers. And a Boolean, which just represents something that's either true or false. It can only have those two numbers. It's kind of like grades. When I assign grades, I just get a list. I can't put in any letter. You can't get a K grade or a good job grade here. There are just a certain list of letters. I can give you an A or B, C plus. There's just a certain category. So Booleans, there are only two values that it can take on, and that's true and false here. And these are special values in our language. And then a string is going to be a string of letters type. Now, one thing to note is string is a special type because it's capitalized. Here, all these other ones are lowercase. we also talk about an uppercase version of these later on. So there'll be an uppercase double and a lowercase double, and we'll talk a little bit about that. But for now, again, that's stuff we don't really need to worry about there. So in general, we'll try to use lowercase int, lowercase double, Boolean, and then an uppercase. So, you know, S for string here. So just note that. One thing I like about this CS Awesome is you can, you know, try out this stuff. So what types should you use to represent an average grade in your course? So what is an average grade there? So I mean, you could say that's a number and you could pick that and you can check, and it says, while int might be, you might throw away digits after a decimal point. So like 89.5 might be your average grade. Oh, so that's a decimal. And you're thinking, oh, what, I need no, I need a double to do a decimal. And you can do that. So you can go through and kind of check this stuff and try these out, which I find useful. Like what type should be used to record if it's raining or not there. And again, you could use a string, say it would say raining or not raining. But here they're really wanting you to think of it as a Boolean, something that is either true or not. Is it raining outside or not? If I say, is it raining outside? You say no, or yeah, kind of like yes or no, and we do true or false here. So I want to choose a Boolean for that. So let's talk about sizes and stuff. Again, they're talking about different sizes of variables. And again, this kind of relates to these different containers and different size containers here. So an integer is stored in a certain number of bits, a certain size on the computer, while a double is takes up more bits, and the way it's formatted is going to be different here. Same with a Boolean, it doesn't need very much space, and it just holds either true or false, a 0 or a 1 actually there. So every variable type has a different size, and that's why sometimes we can't just copy one from the other. We might have to do some sort of conversion back and forth, and we just have to worry about what, you know, if we have a double, we can't store it in an integer, an int value, because it's just too big to store, to fit in this. So now how do we declare these values here? So we're always going to say the type, space, and then the name of the variable. So we would say like int score. Now once we have that, what that does is set up a variable, space, a container to store the score, and the size of that container is int. And then we can say score equals like 4. So we can store some value in that here. Now we can do that all on one line if we want. We can say int score equals 4 when we start, so that declares a variable and sets it up. I'll tend to do it this other way. In this class, I'll declare the variables and later on we'll initialize them. But again, sometimes you will see it this way also. So here's some examples of that, where we say int score equals 0, and then we're going back to our print statement here. Remember how we print things out? We say system.out.print parentheses, and then what we want to print out. And if we want to print out a quote, a string, we'll put it in quotes like this, and then end parenthesis and a semicolon. Now, if we're printing out a variable, we can say system.out.print or print line here, and then parentheses. And then if we just say score without any quotes around it, it prints out that variable, what is stored in that variable. So go to that name there and find out what it is there. Now, we can actually, if we want to do this all in one line, so like if we say double price equals, and we store some value in it here. So here we're declaring a variable and initializing it. And then we're doing system.out.println. We can say a quote And then we can use this plus with a quote, will concatenate. So this will add on now, and then it'll print out this as the price of this. So we can do that. We start with a quote, and then we can do a plus and then a variable. And we can do another plus if we wanted and do some more things, but that's allowed. So we can do it like this, but this basically does the same thing for us. Here. So why don't we try some of this code here and get it set up for now. We can run it here. I can run this code here. Let's see. And it prints it out down below. So it says the score is 0, and that's this. So score equals 0, the score is 0. So on that print line score. So it's printing up. So this part of it, the score is printed out here. The score is, and there's a space there. And then the score, it prints out the 0. And notice, like, if we didn't have this space here, if I were to change this and run it, it would still work, but it would say the score is, and then it would put the 0 right afterwards. Here, the score is 0. So sometimes we want to make sure if we're printing stuff after something else that we include spaces as we want. Here. Now, another thing to watch is that, again, if we just said score in quotes and score without quotes, those are two different things here. I'm going to switch these both to print lines here and run this. So if I put score in quotes, it prints it out as a string of characters or a word, basically. It prints out score. But if I don't put it out in quotes, it's going to look for a variable and print out that variable's value and print it out here. Now, variables are case sensitive, so like here, I could change this to capital S score and it would print that out. But if I change this to capital S score and try to run this, it's going to give me an error. There are compile errors, see below, error. It says system.out.println score, variable score here, cannot find symbol. It's hard to read this error, but it's basically saying that it can't find a variable named score with a capital S here. Because again, I declared it up here with a lowercase. So if I want, I mean, I can move, either way, I would want it, I could have it all match. So if I changed it all to uppercase, that would work. Now it should work because the variable I'm declaring matches the variable I'm printing out here. So now it'll be happier. So again, you can run this here for us. We can also run it in our NetBeans. So why don't we try that? Run this in NetBeans here. So again, I'm going to open up NetBeans. So I've actually saved it to the desktop. I can just go there, or again, I can search for NetBeans and run NetBeans. I get this up here without. Okay. So again, it opened up some my previous assignment here. So I have now 3 projects here and have them open here. I'm going to make a new project just to have some sample code today. So I'm just going to new project. I'm going to leave it to Java and Java application. And again, for the name, I'm just going to say unit 2 samples or something like that. Because I'm just going to try out different things here. Now let me compare these two, this code here to this code here. I want to copy some of this over to here. Let me kick up this font a little bit. So this one starts with the public class test here, and here's my public class here. Now it's down a little bit, and it has this gray area. This is the comments here. Anything that starts with a slash and a star starts a comment saying the computer should ignore this. This is just for humans. And it goes down to the next star slash here. So this is, in our compiler, it grays it out. So that's a comment. So I'm going to actually delete that for now. So it just kind of matches this a little better here. Now this is another comment, slash star, and it gets some information about NetBeans, and then star slash. I'm going to delete that too, just so it matches. And then again, here's one more comment here, slash star down to star slash. I'm going to delete that. Okay, so now public class test2, public class unit. Now mine has a package in it. NetBeans puts things into packages, which basically means folders here. So I have a folder, and inside the folder I have my my class. So it just basically means there's a folder in here. So I'm just going to leave that there and leave it as is here. Now public class here, I'm going to leave that here. Now it's important that this class matches the name of the file in Java. So I can't, if I were to take this line, like right now, this will run fine. It won't do anything about run fine. If I were to switch and put this other thing here, public class test2, I get an error here. Class test2 is public and should be declared in a file named test2.java, but mine is called unit2_samples. So again, we can't, let me undo that. We can't change the name of the class. This class has to match the file name here. So again, when I'm copying code like from a book or from sample, I don't want to necessarily copy the class over. Now the public static main should match here. So if I wanted to copy it, I could copy this whole section over there. Or what I generally do is copy everything inside main. Then I don't have to worry about the parentheses so much. So if I wanted to copy this over, I could copy this and paste it in here. I'm going to remove this. This is another comment. Comments that start with slash slash tell the computer ignore everything on that line from that point on here. So I'm going to take that line and paste in the code from here. So all I've done is basically taken this code and pasted it in here. Now I can run this code, and it should match the code I have over here. The score equals 0. So when I run it here, score equals 0. The price is 23.25, and then prints out false and then true, and hi, Jose, there. So those are the printouts. So it's running the same code here. Now, one reason I'm showing you this is that in some of the textbooks and some of our examples, we'll have the code and you can't run it right there. So here, one thing about CIS Awesome, it's nice because you can run these samples and you can change them right here. But again, we'll see other examples where we don't. And I like to run this code and see how it works. Try out, change different things. You know, like here, I changed score to uppercase. I want to change it back to lowercase here. I have to change it here and here. And then see if I can run it and see if it still has an error. And I can say, I'm going to change this back to the score is, and then print that out. And I want it all on one line, so I'm going to change this back to print here and run that. So again, I like to just try things out. I find that activity of typing, running, thinking, it makes me, that active stuff helps me remember how this works. So I encourage you to try that. When you see sample code, see if you can either run it here and modify it, or bring it over here and see what you can modify and set up, and see if you can break the code. Remind yourself, like, oh, now this is a capital S, remember, because again, if I change it to there, it tells me that's wrong. Here, it doesn't know what system is. Package system does not exist. And it's also useful sometimes to change errors and see what it tells you, so that later on, when you don't do it on purpose, you'll remember. So I changed this to lowercase, and I see the error says package system does not exist. So that usually means I've spelled it wrong here, there. So I just have to make sure I spell it correctly with the uppercase, lowercase. Okay, so let's go over this code some more. We did the score, we did the price. We talked about this plus. How does it print out true and false? So one thing to notice is that notice that false and true are in special, like here, it puts them in blue here, and they're not in quotes. Here we don't say Boolean false, Boolean 1 equals false. We don't say that here. Because this is a string of characters. We where false, and so again, this will tell us some error. Incompatible type strings cannot be converted to a Boolean. So this variable is a Boolean, and it sees this as a string. So again, I have to, and look, it's in green. Also, strings are in green, where false is a reserved word, a reserved value, and it's all in blue in our compiler. It's one thing that this doesn't highlight it as well. That's another reason why sometimes I like to bring it over NetBrains, because this highlights it. So things like integer, double, Boolean, and false and true are all kind of reserved words. We can't, yeah, and we don't have to put them in quotes or anything like that. And we can't like have other things with those same names. And again, when we print this out, when you print out 1, it just prints out true or false here. And again, we can save, create a name here. So I could change it to my name, Tom. And because I like computers to talk to me. Hi, Tom. We have Alexa on our house. I'm just waiting for a smarter Alexa, because Alexa is really, really quite dumb now. I've been spending the summer with some students who are programming Alexa to do different things there. And it's just amazing how nitpicky you have to be when programming Alexa. It makes you realize why Alexa is so dumb. But I think soon Alexa is going to get a lot smarter once we. So what we've been doing this summer is trying to tie Alexa into a large language model, so that when we talk to Alexa, it feeds it to a large language model and then feeds it back. And I think Amazon, from what I hear, is doing the same. I mean, I hope Amazon is doing something better than we're doing as undergrad students. But the whole idea is that I want to talk to, my computer and have it a little smarter than what it is now. So I don't know if you talk to your phone or anything like that, but so far, does anyone have Apple? I've heard Siri is getting better, but I don't think it's that great yet. So did anyone talk to their Siri? So not great yet. I'm hoping it'll get better. So okay, sorry, I got distracted. Okay, so this is, let's go back to CS Awesome here. But again, there's some check your understandings. So it says click on the variable declaration. So they want you to click on that stuff here where we're declaring variables. And you can hit check me and see how you do here. So I like some of these examples where you can go through. And again, fill in the following blank. Age equals blank to declare a variable to be an integer and set its value to 5. So I would say the first blank is int age equals, and in blank, if I want to set equal to 5, I could put 5 there here. And again, if I were to get this wrong and type in like integer here, it would check me and say, no, remember that Java uses just 3 letters for integer. And I'd say, oh yeah, I remember that now, and check that. So I like these where you have to move things in order there. So again, you can drag from here and drop blocks. So whatever block you think is correct, you drag the right one over here. So you can try things like that. Some of this stuff you have to reorder, so it might be out of order here. Then it gets into naming variables here. So you can use just about any name. You can't have spaces in your variables, but it can include letters, numbers, and the underscore here. But we can't have spaces here. But there's a couple standard practices for naming variables. So most variables are set to start with a lowercase number. No, lowercase number. A lowercase letter there for that, because we tend to name classes with an uppercase there, and methods and variables with a lowercase. It's just a way of setting things. So most variables we start with a lowercase stuff. We also often use what is sometimes called camel case here. So if we have a long variable, we can't put spaces in it. So instead, we'll start with lowercase, and then when we get to a new word, we'll put an uppercase letter at the start of that word. And then when we get to a new word, we start with another uppercase, and then lowercase, and another uppercase. And again, camel case it's supposed to look kind of like the humps of a camel here, where every uppercase is hump for the camel. I think that's where it comes from for that. So that's a standard way of doing it. And then we don't put any spaces or any no underlines. Another way I've seen is to use the underscore to do this. Like here, if let's say we wanted this to be called final price or retail price or something like that. We could name it retail space price with a capital P. Here, or we could do retail underscore price. So both of those are good. We can't say retail space price. That won't be allowed. Can't even space. That won't work for this. So we need to either say retail underscore spot price or retail. And again, we could call it retail price all lowercase, but again, just for readability, a lot of times we capitalize that here. And again, if we change that name somewhere, we have to make sure wherever we use that same name here. So, again, this goes through some of this stuff. And there's some challenges, see if you can debug certain things on this. So that's CIS principles. Let's jump to Think Java. So Think Java, it talks about this again. A variable has a declaration has the type and the variable name here. The examples are int that stores like integers like 1 or -5. Char, now we haven't seen char. Char stores a single character like Z or X or A, and these are in single quotes. Now we'll tend to skip over chars until later because students often confuse chars, single characters, with strings. But just so you know, there's a character type here, a char type, and it stores a single character. We don't find it all that useful for a while, so we're just going to ignore it a lot of times. Okay, here's int x here, string, first name, string, last name, int. Now here's a new one, int hours, comma, minutes. So if two variables are the same type, we can put it all on one line with a comma between them here. So that's another way of declaring a variable for this. And then you can assign variables, message equals hello, hours equals 11, minutes equals 59 here. And again, I can try some of this code all for here. So I could take this code and I'm just going to put it over here. String message. Now it's underlining it. Notice this is not a red error, but just a yellow warning light. And it says variable message is neither read nor written. So we declared it, but we never used it, which, okay, that's fine. I'm going to use it soon. So I just know it. And again, I could try some of this code here. And it's probably going to tell me the same sort of stuff here. Now, in some languages, you have to make sure your tabs or your spacing are all aligned. Java, you don't. But again, it is useful for readability if you do here. So here's, and all these are highlighted because, again, we haven't used them yet. So now I can go back here and I can look at this code and I can copy this code in to use them a little bit. So here I'm saying string message and message equals hello. Here hours and minutes and set them equal to some values here. Now notice this is a comment here. And again, the / says ignore everything on the / to the right of this comment. So often when we declare a variable up here, we might go over a little bit and then we might say / and put a little comment for other developers. This message is displayed on the welcome screen or something like that. So again, we can put a comment here. So anything that starts with / is ignored from that point on. Okay. When you declare a variable, it creates a name storage location. That's fine. Talks about legal and illegal. So we talked about this a little bit. Again, if this is a string, we can store a string in it. But if this is a string, we can't store a number in it. We also talk about initializing variables. Now, this is what I find this useful is these memory diagrams, because this is the mental picture I have for this is when I declare a variable called a and I store 5 in it, I think of a box, a container out there, and the label is a and it has a 3 or a 5 in it here. And again, it goes back to this where these containers with labels in it, and we can put things in and out of those containers here. And when I'm actually working on this, I'll actually often do this on paper here. Although sometimes on the computer, I'll just cheat and do it like on a spreadsheet here. Where I'll say, okay, int a, so a is here. And then next to a, we're going to store something, or that should be called a. And we're going to store something here. So I'll just mark that off as a storage location. So we'll just do a order. So this will be maybe what's stored in A. And what are we storing in there? We're storing 5 in A. Maybe I'll send it. Okay. And now I declare a new variable B. So I have another variable called B here. And it is set up to do that. And again, it's going to be storing A. So when I say B equals A, what that means is go to A and get its value and store it in B. So A is 5, so now B will be 5 also. And now when I say A equals 3, it goes up here and changes A to 3. But notice that doesn't change B here. It just changes what's stored in location A up there. So again, sometimes, I'll just draw these out on paper sometimes when I'm working through a program, and just draw little boxes with labels on them, just kind of like they're doing here. And then as we go through different things, I'll keep track of what's being stored in our different variables. And these are called the book calls them memory diagrams. I just drawings here. So, but I find that very useful. And then it walks through printing out variables here and how this works. And again, you can take this code and copy it over here and try to run this code. Now it's giving me an error here because it says int hour is already declared. The variable hour is already defined. So again, sometimes when you copy code over, it might conflict with other code up here. So again, I can delete this code for this. I could also comment it. I could put little comments in here and say, if I put a / before a line, it'll tell the computer to ignore that line. So sometimes I just do that. I'll just put a / in front of this code to say, okay, I've done this, but I want to keep it around just for my notes. And I'll just, when we do comment it out, I'll just put comment, these little dash in front of it. So that it's still there for me, human readable, but it's not, the computer will ignore it. So, and then now this will work. I can run this and see it should print out the hour. The current time is 11:59. So again, you can kind of see this use of prints and print lines for this to print a nicely formatted statement here. Isn't this really exciting? Aren't you very thrilled about variables here today? So I'm sorry, I mean, some of you have probably done programming. Maybe you've done block programming somewhere or something like that. Or if you're in CIS principles, you see block programming there. You'll see the same sort of stuff. You'll declare variables and you use them when you set them equal to value. And block programming often has pretty well the same types. If you've done other languages like Python or JavaScript, again, those work with variables too. Sometimes some languages you don't have to specify the type of a variable. You can just make up a variable and set it equal to some value, and the computer is smart enough to figure out what variable type it should be. So some languages won't make you do all that, but in Java we have to do that. So again, one thing, if you've done any other programming, is kind of think back to those languages or those things and how it kind of maps on to Java and what's a little different in Java. Now, one thing we didn't talk about in this CS Awesome is variables and operators here. So if we want to, we can do certain different operations. For example, we can use the plus, minus. Multiplication is a star and division is a / here. So we can take the hours times 60 plus the minutes here. So we've been talking about printing out stuff, but I can certainly print that out. And in fact, I can take this over here and put it here. Now, I've already declared hours and minutes up above, so I'm just going to delete that here. So now it says the number of minutes since midnight, and it'll print out hours times 60, so 11 times 60 plus the minutes, and it'll print out 719. So this will, we can do basic math with integers or doubles here. We can do stuff like this. We can do some basic division for this. Same with floating point numbers. We can do that stuff. We can store the results of an expression here. So we could say like y equals 1 divided by 3 for this to do some divisions here. So we can if we have like an integer here, we can change things. So we could say like then minutes or yeah equals 34 times or plus 67 here. So we can do expressions. Now, one thing we have to be careful of is in math, you're used to the equal sign being equals, and you could switch this around. So you could say this, but you could also say just as well, you could say it in the other order. You could say, put the minutes on this side of the equation and put the value on this side of the equation. You could say something like that. And in math, this and this are the same, but this isn't a math. This is not an equation. This is an assignment here. So when we're doing assignment, we must have a single value on the left side and equal, and then an expression, which can be a single number or single variable, but it can be a set of operations on the right side too. So this is never going to work for us. So that's an error. So whenever we do this, think of it more, use the idea of it's an assignment or assignment statement, not an equals, not an equation for this. So again, we always have to say that the variable equals is assigned this value. And I'll try to read it that way. I tend to say equals, but I said it really says minute is assigned 34 plus 67, or assigned a value of 34 plus 67. The computer talks about rounding errors. That's a common thing. Operations on strings. So what can you do with a string of characters? So it doesn't make sense to multiply one string of characters by another string of characters. We don't know what multiplication of strings is. We can't divide and we can't subtract. The only thing we can do is do the plus, and that's defined as concatenation. So you can do a plus with some strings. In fact, we saw that sometimes when we print out stuff, we'll say the price is a string and then plus, and then we'll print off another variable here. And this will do concatenation of this. So that shows you some ways of doing this here. There are some issues where when do we work with numbers and when do we convert that to strings here and how that works. So this has some, if you're really interested in some areas here, this deals into some more in-depth stuff than the other CS Awesome does. And also talked about, again, some common compile errors and how to handle those. So, okay, let's look at our final example here. So again, this is from the Intro to Programming textbook here. And again, talks about variables, variable equals expression, right? Equals here is the assignment things, and works through, talks about different data types, and introduces byte, short, int, long, float, double, char, and Boolean. So it introduces a whole bunch of variables. We will tend to use only int, double, and Boolean, and string. It doesn't talk about strings because string isn't what is called a primitive type in Java. So one thing to notice is primitive types start with a lowercase number for this. And then it talks about some more details of what you can store. There are actually 3 types of integers. There's a short integer, an int, and a long integer. And you can store bigger numbers in a long. So it's like going to and get fries. You get small, medium, and large. So integers, you can get small, medium, and large. So a small integer is called a short. medium integer is called an int, and a big integer, a large integer is called a long. We're not going to confuse you with that too much now. So we're just always going to use ints here. So just so you know, we'll always use ints, but there's the other types. And so some of the textbooks, some of the examples, if you have, again, and one thing to be aware of, and when I kind of mentioned this, is like sometimes if you ask AI to generate a solution for you, it might not use ints, it might use shorts, or it might use long. You're like, what in the world is a short or a long? So again, if it does, ask it to regenerate. Can you rewrite this using ints, or I don't know what a short is. Can you rewrite this using an int, or rewrite this using either an int or a double or something like that? So it puts it in a language that you can maybe understand more here. Again, this deals with literals, and again, I find this, some people really like this Think Java because it's much more detailed and goes into a lot more details of this. In particular, if you have had maybe other programming languages, you'll like this stuff. I find this one, that's why I put it third on the list, is my least favorite because again, to me, it's almost too nitpicky. So it's talked about, how to represent a tab as a character and a carriage return. I'm going, that's not that important right now, I don't think. Now it gets into strings and string literals and declaring a string and storing a string there. And then it finally gets into variables and how to declare variables here. And it has a sample program here for this. And again, we could take that sample program and run it. Again, I'm going to leave the public class here. I'm going to leave the public main. And I'm just going to take everything after that. And I'm just going to paste that into this sample one. I'm just going to delete everything in here. And put that program. So I can run this program here and just see what it does for this. And this is nice. It declares variables and also has lots of comments in here describing what this code does. Another thing when you get to problems like this here is that we can ask AI to tell us about this. So if you see something in a book or whatever, we can go to your favorite AI. There. And I can say, as a beginning me about what this code does. Then again, it'll walk you through the different sections of the code and tell you what the different things are. So again, sometimes if you get the code out of the book or whatever and you don't know what it does, you can have it tell, or you can just have it tell you different sections of the code what it does. Okay. I'm going to look at this example that's in our text, or I mean in our notes here, variables.zip here. I'm going to show you two ways of working with the code. This is the way that Chris originally had it set up. I find this a little hard to do every time. So we're going to go through and do it this way, but we're also looking at this way where I just have the code for this. So let's walk through the first way. And this is like the same way when you turn in, and what we do is NetBeans projects come in a whole folder with all this stuff in it. And then we zip up that folder and like you would submit this. This does the opposite. I'm giving you a zip folder. You're going to bring it down, unzip it, and open it up in the NetBeans. So I'm going to download this file, zip file. It's going to go into my downloads folder here. I'm going to go find that folder, open it up. Here's It showed up in my downloads folder. It's called variables, but it has a zipper in it. Now I could click on it and it'll look inside, but I can't use it unless I unzip it. So I'm going to right click on it and say extract all, and it'll extract it. And now it'll create, what it created is a folder here called variables that doesn't have a zipper on it, and everything inside that folder. So now I can go into NetBeans and I can open up that project. So rather than going new project, I can open up a project. I have to go find it. Now, where was it? It was in my downloads. So I don't see downloads over here. So I'm going to go to T. Gibbons and downloads and variables. And notice it has a cup of coffee here. NetBeans symbol is a coffee cup here. So I'm just going to click on that variable that shows, and I'm opening up the project. And it'll show me the project here, for it. So here's my variable project source file. Inside here, there are a couple files here, including this variables one. And now I can try to run this variables one, and it will try to run this code here and prints out the population of Earth here. Okay, so that's one way of doing things. Again, where we can, when we see these examples, and every week for the rest of the course, we'll have these samples here. So you can, every week you can download, and then again, you can watch Chris. You may think Tom's really boring, so I don't want to listen to Tom anymore. And then when you get to that point, you will get to that point, you say, I want to listen to Chris instead. So when you want to, you can listen to Chris. Hey, Chris.
Yeah, I'll talk a little bit about adding some functionality to our programs and throughout these. I'm going to switch to our textbooks.
So again, he'll walk you through this stuff. And this is the code he'll be using is in these ones here. So again, you can download the zip file, uncompress it, extract all, and open up NetBeans and open the project that way. So that's fine. Now, you can also just look at the code here. So here's the code for this. Now, what good does this do me? Well, what I can do is I can make my own little project here, or I can use my unit 2 sample one, but let's just do a new project. Again, I'm going to leave this as ant here and go and give it some name, maybe unit 2 example here. And again, I'm not going to take this whole thing. I'm going to take I'm going to leave the public class there, but I'm going to take everything else. I could do everything inside main or include main here. I'm going to actually just include main and pop it in here for that. So I'm just going to paste it in here, and now I can run it and it should do the same thing. So again, I created a new package here and a new class for this, and I've put here. Now, his example has actually, the variables has some more code. So he has this code and this code here, more code that we'll look at. But this is the general idea, is that you can just paste these in here into your packages here. You can also do a new Java class and add more things to this. But for beginning programmers, I actually think it's good to just have each project here as a single file here that we're working with. So, okay, let's look at this code again. So I don't think, let's see if there's anything. Look through this code. Declaring variables, int number of planets, long population of Earth, double grade point. So again, he's using long here instead of int for this. And I will tend to avoid that. I would make that into an int for this stuff. Now assigning variables, number of planets equals 8, population Earth. Now, when you're assigning values that are longs, when you do that, you have to put this L in here. And again, I find that kind of confusing. So again, I would tend to just use this as an int. Now, one of our problems is that ints can't store really big numbers here. So you'll get this error, integer is too large for this. So we can't store that big of an integer in that. So that's why we're using the long for that. Grade point average here, student name, he has those stored. Int, some assignments, the more assignments here, declares a new variable, talks about this stuff. And we'll talk a little bit later on this week about these different operators. I think you're familiar with most. You've been working with adding and subtracting since 3rd grade, I think, something like that. You know you're adding, subtracting, right? Multiplication, again, we're using, so what symbols do you remember for multiplication? So you use like maybe a little X, like 4x 7 in elementary school, remember that? There, have you used the dot somewhere in math class where you say 4.7 to say multiplication? So you may have seen that. Have you seen any other multiplication signs here? Sometimes it's almost implied with that. Like if you just say like 4x, it means 4 times x. So sometimes it's actually implied there. You don't even have to put in a symbol there. And I don't know, have you seen the star, this one? This is what we use for multiplication, right? And same with division. So again, you've seen the line, the division symbol line with a dot above and below. You probably saw that. And then you probably used the slash before too. Now we'll talk about division. This division, we'll talk about, it could mean integer or decimal division, and they'll be different. And then we'll talk about this remainder or mod operator. You probably have never done a mod operator, so we'll talk about that here also. So we'll talk about those things on Wednesday some more, and we'll walk through some of these examples. Okay, let me wrap up. So again, when you're going through this stuff, I'll lecture through it. If you want to just listen to my lecture, you can on these days. If you want to do this code and play with it, I suggest at some point you play with some of this code. Here, you can do it here. You can do it in CS Awesome. You can do it where you want. So see how you look. And again, and then on Wednesday, we'll start having you actually write more code and doing stuff. So we'll have problems for you to do. I think we'll do our Mad Libs on Wednesday. Okay.